Yeah, let me write the date today. Today I think date is 8th 11 2024. Yeah, let's start example number 4. In the last class I completed 3 problems. Now it is the fourth problem. Yeah, write down now. Main let's try this. Main for I is equal to 1, I less than or equal to n, I is equal to 1, I less than or equal to n, I plus plus, x is equal to y plus z, right? Next one. For I is equal to 1, I less than or equal to n. So remember here, I, right, see this one, I plus is equal to 2. X is equal to y plus 2. Next one, for I is equal to 1, I less than or equal to n, I plus is equal to 10. X is equal to y plus z. And one more thing, for I is equal to 1, I less than or equal to n, I plus is equal to 27. X is equal to y plus z. Now find out what will be the time complexity of this program. Can you try this? What is the time complexity of this program? I is equal to 1, I less than or equal to n, I plus plus, x is equal to y plus z. I is equal to 1, I less than or equal to n, I plus is equal to 2, x is equal to y plus z. So like this. Yeah, good evening everyone. Yeah, please go ahead. What is the time complexity of this program? Try what will be the answer for this? Everyone try this. What is the answer of this? Everyone try. Sunny, can I give answer? Yeah, let me give answer. And one more thing I want to say to all the people who ever watching, right? GATE 2026-27 for GATE CSE, GATE DA, new batches are starting. Go to the ExamPrepTool.com. From there you can subscribe or you can WhatsApp us. We are going to help you. Right? GATE 2026-27 people can happily, right, go to the ExamPrepTool.com. From there you can subscribe. Yeah, fine. So let me start the answer for this. I'm starting. So make sure everyone listen. I'm giving the answer. What is the time complexity of this problem? So this one, I think this program, if you observe, it is the first statement, it is the second statement, it is the third statement, it is the fourth statement. Right? There are four statements are there. First statement, if you observe, see this one. It is started from 1. Every time you are incrementing 1. What is the meaning? I think first it will become 1, next 2, next 3, next 4, next 5, and so on end time. So this will run end time. But if you observe the second statement, first 1, next 3, because every time 2 incrementing, next 5, next 7, next 9, and so on until n. So remember, every time 2 incrementing. It is almost like only odd numbers. It became n by 2. 2 skipping, every time 2 skipping. So it will repeat almost like n by 2 times. But if you see the third statement, always 10 skipping, it became n by 10. If you see the last statement, always 27 skipping, n by 27. N by 27. Now, order of magnitude of every statement I done. Now let me write order of magnitude of total program. Order of magnitude of total program n by 2, n by 10, right? N by 27. So, and one more thing, if you see properly, n common, 1 plus 1 by 2, 1 by 10 plus 1 by 27. It became n into some constant, which is nothing but, right? That may be 5, that may be 6, whatever it is. So time complexity big O of n. You can neglect constant. N into some constant. That may be 10, that may be 27, that may be 100, whatever it is, constant. So time complexity of this program is big O of n. Time complexity of this program is big O of n. So remember 5n is the time complexity. You can write big O of n. Next one, 100n is the time complexity. You can write big O of n. Right? Suppose, right? 10,000 n. Then also you can write big O of n. So be careful. It's a nice problem, right? Please take care. Time complexity of this problem is big O of n. Omega, theta, right? We will see afterwards. Omega, theta also. Check if anyone having any small doubt also. Every statement order of magnitude find out. Right? Always 2 decrementing. Always 2 incrementing n by 2. Always 10 incrementing n by 10. Always 27 incrementing n by 27. Right? This is the answer for this. Yeah, I hope everything is fine. We can move to the next problem. Anyone having any doubt, you can ask me. In the comment section, you can comment if you have any doubt. If you don't have any doubt, right? So please say, let's move to next problem. We will move to the next problem. If you don't have any problem, please say you don't have any problem. We will move to the next one. Yeah, n by 2 also can be written as n. So I will write that also. Suppose n by 5. Suppose n by 5. That is also can be written big O of n. Suppose n by 100. That is also can be written as big O of n. You can neglect constant. That is the meaning of this line. That is the meaning of this line. You can neglect constant. That is the meaning of this line. Check if anyone feels something not clear, let me know. If anyone says something is not clear, please let me know. Time complexity of this program, big O of n. It's a really nice problem. Please take care. Yeah. Let's move to fifth problem. Let's move to fifth problem. Let's move to fifth problem. Example 5. Mean for I is equal to 1, I less than or equal to, I less than n. Equal is not there, so don't worry that much about equal is there or not there. Don't worry. I less than n, I plus plus. Sorry, I less than n, I plus plus. X is equal to y plus z. Next one, for I is equal to 1, sorry, I is equal to n, I greater than 1, I is equal to I minus 1. Above I is equal to I plus 1. I plus plus means what? I is equal to I plus 1. X is equal to y plus z. Yeah, if you want, you can keep equal also, no problem. Don't think much. See, plus 1 minus 1 cannot change the answer. Don't think much. Plus 1 minus 1 cannot change the answer. Don't think much. Next one. For I is equal to 1, I less than or equal to n, I plus is equal to 25. X is equal to y plus z. Next one. For I is equal to n, I greater than or equal to 1, I minus is equal to 75. X is equal to y plus z. So find out what is the time complexity of this program. Go ahead. I is equal to 1, I less than or equal to n, I is equal to I plus 1. I is equal to n, I greater than or equal to 1, I is equal to I minus 1. I is equal to I minus 1. I is equal to 1, I less than or equal to n, I plus is equal to 25. I is equal to n, I greater than or equal to 1, I minus is equal to 25. Yeah. Can you try what is the answer of this problem? Can you try what is the answer of this problem? Check. Let's see how many people will give answer. Yeah, there is a one offer is going on, 41% discount is going on, right? Use the referral code, right? You can get it. Use this referral code, you can get it. Right? Those people who want to join, so use this referral code, you can get it. Yeah, let me try what is the answer for this. Let me try what is the answer for this. Let me try what is the answer for this one. Everyone listen. So it is the first statement, it is the second statement, it is a third statement, it is a fourth statement. There are 4 statements. So first statement order of magnitude, if you observe n. always plus 1. Second statement, order of magnitude, if you see, this is also n. Remember, start from small number, always increment by 1. That is also n time. Start from big number, always decrement by 1. That is also n. The only thing is, one is increasing numbers, another one is decreasing numbers. Here if you see 1, 2, 3 and so on n. But here if you see n, n minus 1, n minus 2 and so on 1. Both are same number of time. First loop also n time, second loop also n time. One is going from small to big, another one is going from big to small. They both are same. I want to say that first statement how many times I executing, second also same. You may say that sir, that is plus, that is minus. Nothing there. Plus means start from small number, keep on increment. Second one, if you observe, start from bigger one, keep on decrement. Now see the third one. See the third one. Always incrementing by 25, n by 25. Always decrement by 75, n by 75. So remember everyone, here I started from small number, always incrementing by 25, n by 25. Here I started from big number, always decrementing by 75, so n by 75. I want to say that, right? Always incrementing by 25 or always decrementing by 25, both are same. I want to say that. If I don't say, you feel that minus is different. No, whatever plus doing, reverse minus doing. So suppose 50 plus 20, 70. 70 minus 20 is a 50. One is increasing, one is decreasing. So if you see these are the order of magnitude of every statement. Now see the order of magnitude of total program. Total program, if you observe, n plus n by 25 plus n by 75, which is going to be n common if you do. So these all will leads to some constant. So n into constant, n into some constant, whatever it may be, which is going to be big O of n. Let me know if anyone having any objection. Anyone having any objection, please let me know. Little doubt also there, you can ask me. Can we go further? Little doubt also there, you can ask me. Yeah, so can we go to next problem? Check everyone. Can we go to next problem? Yeah, let's move to next. I think we done decent work. We done the decent work till now. Let's move to next problem. Let's move to the next problem. Yeah, next problem. Example, maybe I think sixth problem. Example number 6. Yeah, fine. Let's go to example number 6. Main. For I is equal to, careful. For I is equal to 1. I less than or equal to n. I is equal to 1. I less than or equal to n. I plus is equal to 2. X is equal to y plus z. In the similar way, for I is equal to n. I is equal to n. I greater than or equal to 1. I minus is equal to 2. X is equal to y plus z. For I is equal to 1. I less than or equal to n. I, see this one, see everyone. I into 2. Here I is equal to I into 2. X is equal to y plus 2. So y plus z. Now for I is equal to n, I greater than or equal to 1, I greater than or equal to 1, I divide is equal to 2. X is equal to y plus z. Yeah, continue this. Continue this. I is equal to 1, I less than or equal to n, I plus is equal to 2, x is equal to y plus z. I is equal to n, I greater than or equal to 1, I minus is equal to 2, x is equal to y plus z. I is equal to 1, I less than or equal to n, I star is equal to 2, x is equal to y plus z. I is equal to n, I greater than or equal to 1, I divide is equal to 2, x is equal to y plus z. Can you go ahead to what is the answer for this? Try. This is a very nice problem. Let me check. This is a very nice problem. Yeah, try what is the answer of this problem. Yeah, what is the answer for this? Check everyone, what is the answer? So let me try one by one. It is the first statement, it is the second statement, it is the third statement, it is the fourth statement. There are four statements. If you see the first statement, always plus 2, n by 2. If you see the second statement, always minus 2, n by 2. Right? But see the third statement, everyone listen, third statement, always into 2. Everyone listen, always into 2. So remember it is log n base 2. Always divide by 2. That is also log n base 2. If you want, you can verify. Always by 2 or always into 2. always become double. Double means what? First you started with 1, right? 1 into 2, 2. 2 becomes 4. 4 becomes 2 into 4, 8. 2 into 8, 16. So it is going in multiplication of 2. You count if you want, it is going log n time. So how it is? First n, next n by 2, next n by 2 square, next n by 2 cube. It is also always divide by 2 by 2, lastly 1. So both are same. One is incrementing, one is decrementing. It is decrementing. Both are similar. If you see in the reverse order, both are same. Both are same. So please be careful. From this problem, I want to explain. If you always multiply by 2, log n base 2. If you always divide by 2, log n base 2. So this is the order of magnitude of every statement. It is the order of magnitude of every statement. So if you see order, right, order of magnitude of every statement, what is the order of magnitude of total program? Right? N by 2 plus n by 2 plus log n base 2, log n base 2. So remember everyone, in front of n, log n base 2 is very small. Small terms you can neglect. In front of n, log n base 2 is very small. You can neglect. So it will become 2n by 2. 2n by 2. Right? Constants you can neglect. It became big O of n. It became big O of n. Constants you can neglect. Smaller terms you can neglect. Constants you can neglect. Smaller terms you can neglect. Constants also you can neglect. Smaller terms also you can neglect. In front of n by 2, log n is very small. Neglect. In front of right. So that I think constant into n by 2. Constants you can neglect. So answer is big O of n. It's a nice problem. Please take care. It's a nice problem. Please take care. So this problem is nice. Yeah. Sunny, can we go to next problem? Sunny, can we go to next problem? Sunny, can we go to next problem?